Go.
Hi, I'm Vincent Wickwar. I'm professor of physics at Utah State University. What I've been working on for the last quite a few years now has been using Rayleigh scatter LiDAR to study the middle to upper atmosphere. Rayleigh scatter is something we're actually used to, though most people don't know the name. That's the type of scatter that gives us the blue sky. It's also the scatter that means that when we look at a setting sun or the setting moon, they're red instead of white. And so we're just scattering off the molecules, mostly N2 and O2 and some argon in the atmosphere. And this is the prime technique to look at things from 45 to 90 kilometers and maybe even higher. We have 11 years of data between 45 and 90, which gives us a good database to look at for that region. As I said earlier, it's a difficult region to look at. The major technique in the past has been rockets that go through the layer. They measure it up and down, but they're expensive to run many of them. There is air glow, a chemical reaction emitting light that occurs at about 87 kilometers, but it's in a very small region, so that doesn't tell us about the whole region. Why I'm pointing that out is that below about 45 kilometers, there are a number of techniques that work, and above 90, we have a lot more air glow. There's a lot that works. It's this in-between region that becomes the difficult one. And the French developed this technique as something to really use back in 1978, and so a lot of people have been, a few people have been using it since. Now, what we did in the last few years is we made our telescope much, much bigger and used two lasers. So we've gone up to almost to 120 kilometers. Again, a region that's very hard to look at, just continuing that upward trend. So that what we're eventually after is to be able to look at what happens down here in the troposphere and the meteorology, and how it propagates all the way up and affects the atmosphere where the satellites are, and affects their orbits and how quickly they come back down. I don't know, people often don't realize it, but things like the International Space Station that are close to 400 kilometers has to be moved in altitude about once a month to keep it from re-entering. It's a very significant thing. So we've got to be able to keep track of what's going on with the density. And at 400 kilometers, that is greatly based on what's happening at around 100 kilometers. So our getting to 100 is a big help in predicting what's going to happen up there. All of this then is important for what we're doing, well, one, in that region, but two, what's happening with the satellites above. And there are a tremendous number of satellites up there. We're talking something of the order of 1,500 that are operational, and many that are launched each year. We got very excited when the first satellites came up, but we still lost track since then, and there are a tremendous number. So this becomes important. And I guess another thought is that all these satellites may be for the military. In fact, there are many more up there that are commercial, so they're very much involved in our economy. And so all of this fits together as important.